Okay, so for this video, we're looking at John Dalton. So he was the first scientist in recent times to study the atom. And actually, he's kind of the first guy to come up with the idea of it. So he thought that materials must end somewhere. So he said, hey, if I take a block of cheese and I cut it in half, and I take that half and cut it in half, and then the next half and cut it in half, and just keep cutting it in half, assuming you have a knife sharp enough, eventually you'd get down to the smallest thing. And he called that idea, the idea of the smallest unit of matter, an atom. So with that idea in mind, he started doing some experiments. So we're going to look real quick at some of the data or some of the experiments that he did. So this one here says he reacted hydrogen and oxygen together to make water. So if I look at these experiments, I can say, okay, trial 1 here, he takes 2 grams of hydrogen, 16 grams of oxygen, that makes 18 grams of water. And right away I realize, hey, if you add those together, you get the product here. You have 2 grams of hydrogen plus 16 grams of oxygen, that makes 18 grams of water. For trial 2, I have 6 grams of hydrogen, I add it together with 48 grams of oxygen, that makes 54 grams of water. And again, that one I just add them up. For trial 3, though, I start looking at this and I say, hey, I have 10 grams of hydrogen. So between trial 2 and trial 3, I've increased the grams of hydrogen. And I have 48 grams of oxygen. And that still only makes 54 grams of water. Which seems weird because I added more hydrogen. However, if we look back up here, we're in trial 1 and trial 2, I notice that I have for trial 1, there's 2 grams of hydrogen for every 16 grams of oxygen. That's my ratio. I can reduce that down and say every 1 gram of hydrogen reacts with 8 grams of oxygen. We can do the same thing here. So if I say 6 to 48 in trial 2, that's my ratio. If I reduce that down, I can divide both of those by 6. 6 divided by 6 is 1. 48 divided by 6 is 8. I end up with this 1 to 8 ratio. So realizing that, hey, you need 1 gram of hydrogen for every 8 grams of oxygen, I can see that in trial 3, I increased the grams of hydrogen. I did not increase the oxygen, so I don't have that same 1 to 8 gram ratio, so I can't actually make any more water. And something similar here happens for trial 4. Okay, so his second experiment, John Dalton had different metallic cubes, and their data is shown below. So real quick, I can look through this iron. This iron cube weighs 7.8 grams, has a volume of 1 cubic centimeter. Gold, 19.3 grams, 1 cubic centimeter. Well, right away I notice, hey, these are different elements, and they have different masses, even though the volumes are the same. So that tells me, hey, different elements, different atoms of different elements have different densities. Another interesting thing, if I look here, there's a second iron cube, which has a volume twice as big. And the mass of the bigger cube is exactly twice as much as the mass of the smaller cube. So that tells me that, hey, iron is iron, no matter what. It's going to be the same every time, which is another interesting thing to note. Then I can come to this third reaction. He attempted to react some elements together, and the results are shown below. So sulfur and hydrogen, 32 grams and 2 grams. A reaction occurred and a substance formed that weighs 34 grams. So again, here I can see, hey, look, when things react, they're just combining together. He then tried to react gold and iron, and nothing happened. So not every combination of reactants will have a reaction, which is good because, I don't want to react with my shirt on, putting on my shirt every day. That would be bad. Okay, so then we come down, we can look at kind of like the summary here of John Dalton's discovery. So from all of this data that we just looked at and some more, he came up with this atomic model, which is the billiard ball model. It's just a ball. He said atoms are just these tiny balls of matter that make everything up. And there's 5 key ideas that go along with this model of the atom that we already kind of talked about. So number 1 is that the idea that that elements are made of extremely small particles called atoms. The second one is that atoms of a given element are identical in size, mass, and other properties, and atoms of different elements are different in size, mass, and properties. So that comes back to this one. We said, hey, the 2 iron cubes had the same properties. The second one was just twice as big. But gold is different, lead is different, everything is different. The third idea is that atoms cannot be subdivided, created, or destroyed. So this is where, right, he said, hey, this is the smallest thing. It's just a ball. Next, he said atoms of different elements combine in simple whole number ratios to form chemical compounds. So we noticed that at the beginning, right, that there's always 1 gram of hydrogen for 8 grams of oxygen. And that if you mess up that ratio and you don't get it right, you're not going to be able to make any more. You have to get that ratio right. Just like making a cake or something. If I have extra eggs but no extra flour, I can't actually make more cake. And then lastly, he said in chemical reactions, atoms are combined, separated, or rearranged, which we saw with the water. We also see it here, right, where when things react, they combine together, and we're not creating something out of nothing. We're just taking what we have, rearranging the atoms to get something new.